Hi, this is October 2020, Paper 2 Maths AS exam, the last of the mechanics questions, question 3. So a particle P moves along a straight line such that the time t seconds, t is greater than or equal to 0 after leaving the point O on the line, blah, blah, blah. It's modelled like that. Find the value of t at the instant when p stops accelerating. Right, so you need to find out when it stops accelerating. So that's the first thing we need to do. So we need to find out, if something has a velocity and it stops accelerating, it means that it's at the top. So it means that the gradient, or a, equals 0, and that is dv by dt is a. So the first thing we need to do is to multiply up this bracket, which you're going to get, what have we got, 14 minus 2t squared minus 2t squared, oh this is weird, plus 7t. Isn't that weird? I'm not getting this right. 14 minus 2t, 7t minus 14. Good, got to get there in the end. Don't know what's going on. So you've got 14 plus 3t minus 2t squared, or the other way around, minus 2t squared plus 3t plus 14 is probably the way I would do it. So to get acceleration, that is dv by dt, which gives you minus 4t plus 3. You want that to be 0, that's what they've said, when p stops accelerating. So that would give you minus 4t equals minus 3, so t would be 3 over 4 seconds. Okay, so 3 over 4 seconds, or 0.75, whichever you want. So we've done that. And then it says find the distance of p from O at the instant when p changes direction of motion. Okay, so if it changes direction of motion, its velocity is in a particular direction, so we need to find the time at which v is. So for b, we're looking at the time at which v equals 0. So it's gone from a positive, it's changing, and then it will go negative. So to find the value of t, so when v is 0, we've either got you've either got 7 minus 2t, t plus 2 equals 0, so t is minus 2, or minus 2t equals minus 7, so t equals 7 over 2. Can't be that because that's negative, and we were talking that greater than that, so we're talking that. So find the distance. So we now want the distance. So to get the distance when we've got a velocity time graph and a variable acceleration, we need to integrate the velocity. So we had, what do we have? Minus 2t squared plus 3t plus 14. We're going to differentiate that with respect to t, and we're going to do it between 0 and 7 over 2. Okay, so we integrate that and we increase the power by 1. So we've got minus 2 over 3 plus 3t squared over 2 plus 14t plus c, but given it's between 0 and 7 over 2, that doesn't matter. And then we sub it all in. Okay, so I might obviously cheat and do it like this. So I've got, so we end up with s equals 931 over 24, or 38 and 19 over 24, or 38.79166 metres, or 39 to 2 sig figs. Good.